So a couple things to note over here. The A's are kind of reversed, and what that means is if it's positive, it's going to the right. If it's negative, it's going to the left. And you'll see what I mean when I actually plug in numbers over here. But what you notice is that the A is very close to the X, and they're inside the same bracket together. Whereas the B is completely outside the function, the f of x. It's outside, so it's going up and down. Now, let's say f of x, y is equal to f of x looks like this function over here. Let me draw something a little bit nicer. Okay, how about there? Okay, since it doesn't seem like I can draw a straight line with the iPad. If I have y is equal to f of x minus 3, okay, now I just want to focus on this number here, and this is positive. What that means is if it's positive, I'm shifting to the right by 3. So every single point, this value here, this value, this value, this value, this value, it moves to the right by 3. 1, 2, 3. So here, 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 and here. Okay. Boom, that's my new line. If I somehow did something different, let's say if I do this, y is equal to f of x plus 2, I can actually rewrite this. Let's do, I can rewrite this as y is equal to f of x minus negative 2. So this number here is negative. Even though it's plus 2, it's technically a negative number. And what that means is you shift to the left, okay, by whatever that absolute value of that number is. Okay. So this and this are the same thing. You're shifting to the left by 2. So every value gets shifted to the left by 2. And there you are. And that's your new function here. We can do the same thing now that we have the b. So let me do my original function here again. Let's say I have, okay, I'm just trying to do this as best as I can. There. Yeah, it seems pretty straight to me over here. If that's y is equal to f of x, then what is y is equal to f of x plus 2? Well, the b is positive, which means we go up 2 then. So every point goes up. 2, 2, 2, 2, 2, and 2. Boom. That's my new function. And then if I want to do the opposite, let's say I want to do y is equal to f of x minus 4, then every single one of my points goes down 4 spots. Because see, 1, 2, 3, 4. Okay. And that's my new line. Oops. And we can combine the a's and the b's together. So let's say this is my original function, f of x. What if I did y is equal to f of x minus 2 plus 1? This means, because this is positive, I go 2 to the right and 1 up. So every single point is 2 to the right and 1 up. Here becomes here. Okay. This becomes this point. And so on and so on and so on. So that is my new function. And you could play around with this however much you want, but just know that whatever number is inside of this bracket that goes with the x, that is a left to right movement, and we call that a translation, okay, a horizontal translation. So let me write that here. A determines your horizontal translation. Whereas the B determines your vertical translation. Alrighty, so let's do something like this. We know that y is equal to f of x is given by this red function over here. So what is y is equal to f of x plus 2? You can either rewrite this as y is equal to f of x minus negative 2, or you can just know that this is the opposite. So because this number is negative, we are moving to the left, and we're going to move left 2. Every single point here moves to the left by 2. So let's say if this is your original function, you have here going all the way here. Nope, here. Huh. This does not want me to go up here. All right. Let's see. There. Okay. And then let's say this is your original function, like this, and then you have this over here. All right, good enough. You move every single thing to the left by 2, so I'm just going to cheat the system. I'm just going to, I'm going to highlight the whole, oh crap, sorry. Highlight the whole thing and move it to the left by 2. There. That's what my function looks like now. Okay. Redo. There you go. That's what my new function looks like. So I'm going to copy and paste that again. Oops, not this. Copy and paste. So my original function looks like this. Now, if I go over here, right 3, up 3. So everything goes right 3, 1, 2, 3, and up 3. 1, 2, 3. There. It's a bit outside of the lines for the left section of the graph, but I'm hoping you understand what I mean over here. And then we get into our actual functions. Y is equal to x plus 2 squared minus 2. Let's look at our original base function. This is y is equal to x squared. And remember the points that we plugged in. 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. We can draw a parabola over here if we'd like. There. And it keeps going upwards and upwards and upwards. Copy, paste. I'm going to make this one black so it's the original. So if we have y is equal to x squared, then this whole thing means, well, we're moving 2 to the left and 2 down. So 2 to the left, 1, 2, and 2 down. 1, 2. And there you go. Now let's look at the second function over here. Y is equal to x minus 4 plus 1. Remember that an a square root almost itself acts like a bracket. So this is y is equal to root x. Remember that the points we have are, let's do this, 0, 0, 1, 1, 4, 2. We can't really do 9 and 3, so we're just going to have to live with what we have over here. Something like that. Okay. What this tells us is we're moving 4 to the right and 1 up. So I clearly didn't think this through because I don't think I have enough space, but we'll live. Start with your original, move 1, 2, 3, 4, and then go 1 up. And that is your new function right there. The one that is the trickiest to do is the y is equal to 1 over x function. Okay. And I'm going to draw what that looks like originally again, because when you move these, you also have to move the asymptotes. If you forgot what an asymptote is, go look at my previous video, but you have this as your vertical asymptote, and you have this as your horizontal asymptote. Then you start getting points, namely 1, 1, and -1, -1. Okay, these are the points you must input all the time. There. Good enough. And here. There. Okay, it's a little bit messy, but we'll live. There. Okay. So what I mean by you have to move your asymptotes is that whatever you move for one thing, everything else has to move.
Excuse me, please, if you're in an EA, can you please come to the entryway? All EAs, please come to the entryway.
All right, so there's a bracket over here because it's attached to the x. This is 3 to the right and 2 up. So I'm going to copy this over here, duplicate. Maybe I'll make them all a different color, make them pink. Okay, there. So we move 3 to the right. So 1, 2, 3, and 2 up. 1, 2. And there you go. That is our new function. So this covers the idea of translations, moving up, down, left, and right. Next, we have reflections. Whenever you have a negative x, this is a reflection in the y-axis, otherwise known as a horizontal flip. And I'll explain what most of this means visually afterwards. Now, if you have the negative outside of the function f of x, this is what we call a reflection in the x-axis, or a vertical flip. If you have the negatives on both the inside and the outside, this is a reflection in both of the x and y axes. Is that how you say axes for plural? Okay, I'm not sure. And this is a horizontal plus vertical flip. We're going to do some examples. Let me go ahead and copy an image from above, down below over here. Let's see, what can I use? I'll use this. Oops. Copy. And let me erase this over here, or there. Okay. There, we have something like this. Let's say our original function looks something like this. There. So if I do a reflection in the y-axis, that means this y-axis here acts as a mirror, and everything is reflected over. So my new point will be this. There. Everything is flipped over the mirror. Boom, boom, boom. All right, now let's go back and do something like this one here. let's say we have a function, same function like this, but if the negative is on the outside of the function, we have what we call a vertical flip, or a reflection in the x-axis. So the x-axis acts as a mirror, and everything is flipped from top to bottom or bottom to top. If we have a negative on both the x and the y, that means first, I like to go from left to right. So first, you flip vertically, which means it becomes here. And then you flip horizontally. So this one, you mirror once, and after that, you mirror this part again. So it becomes this. You first go from here to here, and then here to here. And this is your final product. All right, so let's do some of these using functions we actually know how to use. Okay, let me get this over here. Let's say you have y is equal to x plus 3. Actually, let's do x plus 3. Sorry, just y equals x. Y equals x looks like this. There. Once again, I can't actually draw a straight line here. For some reason, this is what happens. Okay, it doesn't actually hit the actual points. Yeah, I'm not sure why. But there, y is equal to x. If I want to find a reflection in the y-axis, I take a negative x and I plug it in here. So y is equal to negative x. Becomes our new function, which is just y is equal to negative x. So if I plug it inside the f, then we just have a reflection in the y-axis. So the new thing is this. Because this goes from here to here, and here to here. Let's do something else. What if I have y is equal to x squared as my original function? If I plug in negative x, y is equal to negative x squared, you're going to realize this is the same thing as x squared. So if this is my original, here, 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 and, here, okay, and I reflect it in the y-axis, okay, nothing happens because a parabola is already identical. So this point goes to this point goes to this point, and the middle doesn't reflect. Nothing actually happens. If I have y is equal to x cubed, however, well, we get a couple points here, here, here. I think it was this one here and this one here, and it looks something like this. And here. If I plugged in negative x into all the x's here, y is equal to negative x cubed. I end up with y is equal to negative x cubed. So what happens is that if you reflect along this line, everything changes. Here, 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 and here. So we get something like this. Oh, and don't forget this. So a reflection just means if we want to plug in a negative x into all the x's, take this and plug it in here, then that's a reflection in the y-axis or horizontal flip. Okay. Let's do the second one now. Let's say I have y is equal to root x, which we know the point should be here, here, and here. And it keeps going, going, going. If I want to do negative f of x, remember that this is already f of x, then y is equal to negative f of x. Because it's outside of your function, then you have a vertical flip, or a reflection in the x-axis. So everything is flipped upside down. Okay. There. And if you want to do a double flip, we'll use the same picture over here. First, you flipped top to down, and then you have another mirror like this. And then this becomes here. So that's the idea of a reflection. Okay? Depending on where the negative is, either it's inside your function or outside of the function, it changes the landscape of most things. All right, use the function y is equal to x squared as a base and create a new graph that is a reflection in the x-axis. Reflection in the x-axis, this means this is a vertical flip, which means we add the negative outside of the function. If the function is y is equal to x squared, then outside of the function is we put a negative right on the outside. A reflection in the y-axis means, oh, it's a horizontal flip, meaning we plug in negative x into all the x's. So y is equal to x squared. If this is your original function, your new function is y is equal to negative x in brackets squared. But this is just y is equal to x squared because the negatives cancel out, like we learned earlier. And with the reflection in the y-axis for the y equals x squared graph. The parabola, if it's reflected, it still becomes the same thing. Reflection in both just means, well, if you have y is equal to x squared, then you put the negative on the outside and the inside. And this is just y is equal to negative x squared. Do the same thing over here. Use y is equal to x squared plus x as a base. A reflection in the y-axis. This is a vertical flip. So if y is equal to x squared plus x, then y is equal to negative, and I'm going to put this in brackets, x squared plus x. That is your new graph. And if you really want to be diligent about this, this is y is equal to negative x squared minus x. A reflection in the y-axis over here is a horizontal flip, which means you plug in negative x into all the possible x's. So if y is equal to x squared plus x, your new function is y is equal to negative x squared plus negative x, which does, unfortunately, change the function into x squared minus x, which is a tad bit different. Finally, here and here, y is equal to x squared plus x. Remember, we first put the negative on the outside, and then negative on the inside. So negative x squared plus negative x. So we put the negative on the outside, and then we replace all the x's with negative x, which gives you y is equal to negative x squared minus x, which is y is equal to negative x squared plus x. What transformation has occurred for y is equal to x squared plus x to y is equal to negative x squared minus, this should just be x. I don't know why I have 2x. Okay, sorry about that. All right, this one should be fairly simple because these were both positives and they became negatives. So it seems like we went from here, x squared plus x, to putting a negative on the outside, and then x squared plus x like this. So the change that has occurred is that we now have a reflection in the x-axis, otherwise known as a vertical flip. For this video, we will end off with this last part. Let's say we have the function 3, 2. 3, 2. What happens when y is equal to negative f of x? That's a vertical flip. So your new point is here, 3, negative 2. We'll use blue for the next one. If your original function is the black one over here, y is equal to f of negative x. Because the negative is inside the brackets, you have a horizontal reflection or reflection along the y-axis. So your new point is here. If you have a double flip, you first go to the red and then you flip it. So your new one will be, let's do purple here. So the blue is negative 3, 2, and the purple now is negative 3, negative 2.